In this video, we'll explore the Pythagorean identities. On your formula sheet, we have three Pythagorean identities. They're all based on a Pythagorean theorem, a squared plus b squared equals c squared. The first one is straightforward enough. Sine squared of theta, some angle, plus cosine squared of the same angle equals 1. That's the primary one, and that one you, I think, should be able to remember without too much trouble. All the other identities that we're going to see here, again, there are three of them that are on the formula sheet, but we're going to expand this out so you can see that they actually can be manipulated to form 9 Pythagorean identities. And you kind of need to understand that to identify these things when you're using them to solve equations. And you'll see what I mean as we get going. But the other two Pythagorean identities from your formula sheet, 1 plus tangent squared of theta equals secant squared of theta, and 1 plus cotangent squared of theta equals cosecant squared of theta. Now, if we take these second two identities and just say, okay, we're not going to try and remember those, but let's see how we can derive them from this first identity, this one right here. If we can just remember that one, and let's say that we want an identity that has tangent in it. Well, if we start with sine squared of theta plus cosine squared of theta equals 1, and we realize that tangent of theta is equal to sine of theta over cosine of theta. You'll recall that from our work on the unit circle. Well, what can we do to get tangent into our equation here? Well, what if, since tangent equals sine over cosine, what if we simply divide both sides of this equation by cosine squared of theta? Well, the first term becomes tangent squared of theta. The second term, well, cosine squared of theta over cosine squared of theta, well, that's just 1, right? Something divided by itself, that's just 1. And then on the other side, well, 1 over cosine squared, well, cosine is the reciprocal of secant, right? So equals secant squared of theta. And you'll see that that is our second Pythagorean identity up here. Well, what about the other one? What if we want cotangent in our identity? Well, remember that cotangent of theta equals cosine of theta over sine of theta, and we can basically do the same thing. So in this case, we'll take our original, very simple cosine squared of theta plus sine squared of theta. Notice that I changed the order here. It doesn't really matter. Equals 1. And we want to get this to look like cotangent. We want to have a cotangent expression in here, term. Well, let's just divide all the terms by sine squared actually, of theta. Divide by sine squared of theta. And again, simplifying, well, cosine squared theta over sine squared theta, that's just cotangent squared of theta. Sine squared of theta over sine squared of theta is 1. And the reciprocal of sine squared, or the reciprocal of sine, is cosecant. So this expression becomes cosecant squared of theta. And there again, you have your third Pythagorean identity. Now, what if we had a problem that didn't look quite like this, I want you to also realize that we could derive two other identities from each of these. In the case of this first one, what if we subtracted cosine from each side of this equation? We'd end up with sine squared of theta equals 1 minus cosine squared of theta. Or, let's say we subtracted sine squared from each side, we would end up with cosine squared of theta equals 1 minus sine squared of theta. So you can see how this same process could be used to derive similar formulas for each of the other two identities. So there you have actually 9 Pythagorean identities. Now, you don't have to memorize all these, but it would be helpful if you're able to recognize these when they show up in equations later on.